now. Sorry. Okay. Yes, that's another way. Yeah, when you buy like a bunch of boxes from UPS or USPS or FedEx or whatever, they come like this, and then you have to put them together. Okay, so that's basically what a net is. And the reason I put it as a net is because the net kind of helps us to see it a little bit better, right? Because a cube or a prism like this one, you can only really see 3 out of the 6 total sides. But when you unfold it kind of like this, you can kind of see each of the 6 sides.
Wait, but what, does it really make a difference?
It doesn't make a difference. I'm just showing it both ways because for some people it's easier to visualize it one way than the other.
Oh, like oh yeah, we're learning about surface area.
So like on this I keep saying triangle, on this prism, here's the pink one. I'm going to kind of match everything up. Corresponds here. Here is, let's see, the other. I know it's a little bit hard to see. Here's the other smaller face. Now, all the rest of them can basically go in any order, but let's just say that this top one. Okay, would this one on top, would it be the first one or the second one? Notice they're slightly different sizes. So would this yellow one correspond to the top one or the second one?
The top one. The top one. Wait, no, I'm seeing it wrong. It's the second one. Yeah.
It's the second one because this is 2 and then this is 4. So we're looking for the one that's 2 meters and then 4 meters. So it goes here. Let's see, what other color can I use? Let's use blue. Okay, the one on the other hand, this one would correspond to the top one. And then the other 2 are kind of hard to draw, to like color in because all the other ones are already colored in. But there you go. It's a little bit easier to visualize it that way. So the reason the net is helpful is because the net can help you to see, okay, I have how many different rectangles? I have 1, 2, 3, 4, 5, 6 rectangles. I'm going to find the area of each of these, and then we're going to add it all together, and then that's your surface area. So let's go ahead and try that out. So the first thing I want to do is let's just write it kind of like a formula. So we can call this R1, R2, 3, 4, 5, and 6, because I have 6 different rectangles. So what I'm doing is I'm adding those all up. I'm adding all the areas. Right? But a lot of these have things in common. So for example, R1, what would be the area of R1? The area of R1, how would I find that? Good, 4 times 1.5, because it's length times width. So 4 times 1.5. How about R2? What's the area for R2? So it might not be fully labeled, but you can figure it out. How long is this side? How long is that side? Good. Now, I know that that's the final answer, but I'm just breaking it down still. So that was 4 times 2. Yeah. So I know that we can do the math, but right now I'm just breaking it down because I just want you guys to notice something. Okay, how about R3? What would R3 be? 4 times 1.5 again. Okay, keep it going. R4. Let me move this down a little bit. 2 times 4 again. R5. Two times 1.5. And how about R6? Same thing. Good. Okay, I ran out of room, but that's 1.5. So what do you guys notice? What comes up? What's going on here? Is there a way to consolidate or to bring things together? Yeah, because what do we notice? Okay, we have 4 times 1.5 right here, but it also comes back over here. So there's 2 of those, there's 2 of these, and then there's 2 of these, right? Now on the original diagram of this prism, 4 would be the length, 2 would be the width, and then 1.5 would be the height. So let me just write that out really quickly. So on the original one, the length is 4. The width was 2. And the height was 1.5. So if I kind of rewrite this, I actually skipped a step, so I'm going to write it over here. This would be 4 times 1.5. So that would be the length times the height. 4 times 2 is the length times the width. Length times height again. Length times width again. And then 2 times 1.5, that's W times height. Okay. So final thing. Sorry, I know I'm writing a lot. That's just because I want you guys to see where everything comes from. Now I can basically combine like terms because there's 2 of these, right? So I have 2LH. There's 2 of these. So I have 2LW. And then there were 2 of these. So 2WH. Everyone with me so far? Any questions so far? Okay.
No.
Now, there's even more that I can do.
Miss, I have a question.
Okay, what is it?
How did you make such a simple problem so complex?
Because but am I though? Because think about it. Look how much we started out with, and I'm starting to make it smaller and smaller. So I don't know if that statement is right. I think I'm actually making it easier, but you just don't know it yet. Because now I have one last step. What can I factor out of all 3 terms? What can I factor out? What do all 3 of these have in common? The 2. So I'm just going to factor that out. And now I have LH, LW, and WH. And that is my formula for surface area. Now I wrote A, but usually you're going to see this either SA, or you might see it at what is it called? Why am I forgetting what that's called? I don't remember what it's called, but you might see it as a little s underneath. Either way, this is our formula. And now we can plug everything in and get our answer much more easily. If you do it the really long way, you're still going to get the same answer, but you're going to be doing more work. So using the formula allows us to start to kind of do it it is still a little bit longer, but you're probably going to make fewer mistakes that way. So 2 times 4 times 1.5 plus 4 times 2 plus 2 times 1.5. Now go ahead and using those numbers, let's all together now, you can use your calculator. Let's come through and get an answer. Janelle's got 44. Does anyone get the same answer or a different answer? Ooh, 88. Okay, you multiplied it times 2. Are we getting the same answer as Janelle's? Are we getting a different answer as Janelle's? I'm waiting to hear from more students. So Perla agrees. That's 2 students, but I have a lot more. Okay, Rio's got 88 as well, but also got confused. So where'd you get confused?
My calculator said it after I spelled confused on it.
Okay. Anyone else? I'm curious. Okay, well, let's see how we get that. So what do I get? Let's simplify. What do I get here? 4 times 1.5. 6. 4 times 2. 8. 2 times 1.5.
Oh, I thought I said 15 with.
Oh, I was like, where is everyone getting this number
ABC.
from? It's a 1.5, guys. Where would I have gotten 15 from? There's no 15 anywhere here.
The
See,
top was
y'all
literally
just
so
need
small.
numbers.
We thought it was 15.
Okay, so now do it and see what you get.
ABC.
I was so confused. I was like, I'm gonna wait for someone to get it right, and then nobody got it right.
That's my point on when I got confused.
Okay, we get 34. That's correct. So the surface area is 34, and then do I have yeah, I have meters squared. Okay, 34 meters squared. So that's basically how it goes for a prism. There is the long way, and this is the good thing about surface area. If you forget the formula, you can always do it the long way, right? Because you know surface area, all we're doing is adding up the area of each individual face. So if you forget the formula, no big deal. Just do it the long way, add each individual area up. But formula definitely helps us to do it a little bit more quickly. Questions? Nice, Perla, but I can't see it, so. Okay. All right, here's another one. This time I have not a rectangular prism, but I have a triangular prism, which we've worked with before. But now let's think about what's similar and what's different. So we're still doing surface area, which means I'm adding up the area of each individual face. So let's start by doing it the long way. We'll do it the long way, and then we'll see if we can come up. Why are you upside down? And then we'll see if we can come up with the formula correctly.
Looks like Perla and Tyrone are in Australia now.
There we go. Hi. Hi, Janelle's. I never get to see your face.
That is true.
Well, your hair looks very nice, Perla. Nice and straight. We'll see how long that lasts because it's been so rainy today. Yeah.
Your hair looks
I got a haircut.
And you got a haircut too. Nice. Do you have like a fade or something? Yeah. Nice. That looks good.
Yes.
All right. Haircut Monday.
I haven't got a haircut.
Now, let's take a look at this situation. So in the first example we did, I had 6 rectangles, but now what do I have? I have 3 rectangles and 2 triangles. Now, are the 3 rectangles the same? No. At all, right? Each of them is completely different. So we have 3 rectangles, 2 triangles. Are the triangles the same? Are the triangles the same? Yes, they are. They are. Because here's 9. Here's the 9 over here. Now the 9 is also 9 on the other side. So this line right here, that's also 9. So even though they aren't labeled all the way over here, we know that this is also 9 centimeters and this one's also 12 centimeters. So they are the same. So we have 2 identical triangles and then 3 separate rectangles. So R1, R2, R3, and then I'll call this T1 and T2. So surface area, we're going to add everything up. That's going to be R1 plus R2 plus R3 plus T1 plus T2. Okay. Now, the formula for each of these, now let's kind of label some of this stuff. If I label the 14, that's my base. Or no, that's my length. Here's my width. Do we know the height of this prism? Rios, if you want to try it your way and then see. So, okay, Parla gave me R1, but guys, my question right now is, do we know the height? Do we know the height? Okay, no, we do not, right? Don't know the height. So how would I find the area of this triangle? Any ideas? Because I'm going to need it. I need T1 and T2. I need the area, but I don't know the height. Because that would be my height. Kind of stuck, aren't we? A little bit, yeah. So the thing is, I kind of gave you guys a trick question because with a triangular prism, there's really only 2 ways that you can figure it out. One way is if it's a right triangle, because let's pretend it's not, but let's pretend that this is a right triangle. If this was a right triangle, guess what? You could turn it so that this is the base and then the 12 would be the height. Do you guys kind of see that? Turn in your head, turn this
Why
triangle.
not just use the protractor?
The protractor?
No. Procrastination theorem.
Pythagorean theorem?
Yes.
Well, that's the thing is we can't because this is not necessarily a right triangle. That's the problem. If it was a right triangle, we would actually be just fine. But because it's actually not a right triangle, we can't use the
I'm sure
Pythagorean
about that.
So
theorem.
how do you solve this?
You can't. That was my long story short. But
Wow,
the
so you
only thing
put us
I
through
wanted
this
us
for
to
no reason?
notice, what I did want us to notice is that the two triangles are the same. So the formula, the only thing we can kind of condense or simplify is that we can bring these two together. So the surface area is going to be R1, hold on, R1 plus R2 plus R3 plus 2 times the area of the triangles. So that's the only thing for triangular prisms that we can really do. But in the next example, I'll show you one where they actually give you the height. So if you know the height, it becomes a lot easier to do it. So let's go ahead and try that. So in this one, notice this one is a right triangle. So when we get to it, it'll be a little bit easier. But let's start with the rectangular prism. Who can remind me what is the formula? Who wrote it down? For surface area, that's not the surface area formula. Did I say volume? Maybe I said volume, but we're doing surface area. I don't see it yet. Two LH plus WH plus LW. Good. And if that's something you forget, just remember you're doing each combination. You're doing length and height, you're doing width and height, and then you're doing length and width. And now we just fill everything in. All right, 96 plus 144.
I didn't
Hold
really
on.
use the formula. I was just
Oh, you were doing
yeah.
it.
I was just multiplying whatever.
Okay.
Multiply it by 2 and just bam.
Oh, I see. So we get, if we do it this way, we get 96 plus what? 72 plus 48. So the way that Rios did it, he multiplied by 2 first, basically,
Yeah.
rather than doing it at
Wait,
the end.
actually, I don't know what I did. I'm just doing what I'm doing.
Well, let's see if we get the same answer. 96 plus 72 plus 48. I got 216. Yeah. 216 times 2,
That is not the way I did it.
we get 42 centimeters squared. So how did you do it? Did you kind of do it like you did 8 times?
Visually, 8 times 6, 12
Mhm.
times 6, 12 times 8. Just, yeah, multiply all that by 2 there.
Yeah. Yeah. So you did do it the same way. You think you're doing it different, but you are doing it the same exact way. You just did it in a different order.
Yes.
Questions on rectangular prism. That's the easier one.
No.
Okay. Now, this one's a little bit more challenging. So let's start with the rectangles. So I have 3 rectangles. Can anyone give me the numbers for the first rectangle?
8 times 12.
8.
Oh, wait,
10.
wait, never
We're
mind. I'm
doing-
looking at the wrong thing.
Oh, that's okay.
Wait.
Which one are we doing first?
We can do 10 times 20.
10 times 20. Good. So that's going to be this rectangle, right?
Mhm.
Okay. All righty. Okay, what's another rectangle from here? So she just got this rectangle off to the left side. Give me another rectangle from this prism. Give me some numbers to put into my formula. 20 times 24, good. So that's the other side, right? That's this one over here. And remember that we're adding. All right. And then what's the last one? $20 times 20, no, because those are both the height. Do we know this value down here? Oh, we don't, do we? Okay, so that's where we come to a bit of an issue because we don't know what that value is, but can we find it?
Yeah,
How?
I don't know.
You do, you've said it before, kind of.
Probability theorem.
The Pythagorean theorem. Because what type of triangle do I have in this case? I have a right triangle, right? So I take this triangle from the top. I'm just going to draw it over here. This is the top of my prism. I have 10, I have 24, and x, we're going to solve for x using the Pythagorean theorem. So let me set that up. Which one's the hypotenuse? The 20, no. Yeah, no, the x, okay. You can always tell because remember the hypotenuse is on the opposite side from the right angle. So 10 squared plus 24 squared equals x squared. We do a little bit of math. What's 24 to the power of 2? $576. Plus 100, that's 676. What's the square root of 676? 26. So in this case, we were able to find the missing length. Sometimes you can, sometimes you can't. So you really have to check it out and see for yourself if you're able to figure it out. So now that we have that final side length, we said, okay, now we're looking for the third rectangle. The front of this, the one that's facing us. It's this one right here. What's the area formula for that one? What's the area for this rectangle, this orange one that we just found the length of it? Good, 20 times 26. Okay, so I have my 3 rectangles, I'm still missing my 2 triangles. But the 2 triangles, we already have, we have the base and we have the height for those. You can try and picture it this way. So here's my triangle. Think of it like it's this way. Turn it in your head. So what would be the formula for this triangle? What would be the area formula for this triangle? What's the area formula for a triangle in general? Okay, there we go. One half base times height. Guys, the lack of participation today, y'all are starting on a low note. You
Do
gotta
I have
pick
good
it up.
participation?
Yes, you do. You're doing good. But when I ask a question, I expect an answer much faster than that at this point in the year. Area is 1/2 base times height. So for these 2 triangles, remember there's 2 of them. So it's 2 times 1/2 times 10 times 24. Well, what happens to the 2 and the 1/2? What happens when you have a 2 and a 1 times 1/2?
Oh, it becomes 1, right?
Yeah, it cancels out to 1.
Miss, it doesn't matter in like what order you did that. So if I did like 10 times 1/2 and then multiplied it by 2 and 24, would it matter?
It wouldn't matter. You
Okay.
can do it in any order. But now that we know that cancels out, that saves you a step. Does that make sense? All right. So now we have everything we need. Let's go ahead and find out what is the surface area of this triangular prism. So start simplifying things. What do we get?
200
Mhm.
plus
She's reading the chat.
480 plus 520 plus 240.
Miss, Perla, were you just reading the chat?
No, I was doing it on my calculator.
Good.
Okay. Oh, I wrote 180. I meant 480. Sorry. Okay. All right. And now we add everything up. What do we get? (1,440) inches squared. All right. So kind of with prisms, when you're trying to find the surface area, really the most important thing, if you forget everything else, the most important thing is you just have to remember, okay, I'm adding up the area of every single face. So what's the area of the rectangle? What's the area of that rectangle? What's the area of this rectangle? What's the area of the triangle? And then the other triangle, there's 2 of them, and you're going to add everything up. So that's kind of the nice thing about surface area, is that you can memorize some of these formulas, but at the end of the day, the formulas are just telling you what you already know. They're telling you, okay, add these things together and see what you get. The only thing with surface area is that it usually takes a much longer time because there is a lot of steps involved. So you have to be very careful. Questions on surface area for rectangular prism and triangular prism? Questions going once? Going twice? Okay. All right, now let's go ahead and take a look at a cylinder. We're still going to be doing the same thing. We're going to be finding the surface area Well, let's take a look at the net of a cylinder. What is a cylinder basically made up of? So we've got two circles and then a rectangle. Now, look at what they did here. They labeled this rectangle. They said, okay, this is the height. This matches here. But where does this come from? 2 pi r. What is that? Where does the 2 pi r come from? Good. That is the circumference. And let's see why that is. Well, that's because if I take this circumference, I'm going all the way around, that's going to match up with this length right here. So that if you think about it, think about like, I'm trying to see if I have anything here. I don't think I do. Well, kind of do, but not really. Have you ever taken a bottle of water or like maybe a can of beans or something, and it has the wrapper all the way around, and you unwrap it, you like peel it off? Yes, okay. When you peel that off, that wrapper that goes all the way around your can, well, you can flatten it out and it turns into a rectangle, or you can make it into a bracelet, sure. But either way, that rectangle, the length of the rectangle is what you've wrapped around the can of beans or whatever you have. So the length of the rectangle is the circumference of the circle. So let's go ahead and let's kind of break this down. I have two circles plus a rectangle. So the surface area is going to be the area of the circle. Now, are these two circles the same or different? Are the circles the same or different? They're the same. Okay. So I have two circles and one rectangle. But let's break it down. Because what's the area of a circle? What's the formula for the area of a circle? Pi r squared. Oops. And then I have a rectangle. Well, here's my rectangle. Fill in the blanks. What would be the area of the rectangle? Length times width. But here, what is the length and what is the width? Two pi r times h. Okay, I'm going to simplify this a little bit. I'm just going to, this 2, I'm going to multiply. I don't need to distribute it. I'm just kind of taking away those parentheses. What do these two terms have in common? What do both of them have? They both have 2 pi r. Do we agree? They both have 2 pi and r. Now, this one has r squared. So let me rewrite that a little bit. This is 2 pi r r. Because when you multiply r times r, you get r to the power of 2. So both of them have 2 pi r, which means I can factor that out. And if I factor that out, what am I left with in the first term? What am I left with? When I take out 2 pi r, what's the only thing I'm left with? Good, there we go. I am left with r and h. So I factored this out and I'm left with r over here. And over here I'm left with h. So they go inside the parentheses. Remember that factoring is just the opposite of distributing. So if I distributed this, I would go back to where I started. So I have 2 pi r times r plus h, and that is my formula for the surface area of a cylinder. And now here's an example. We can actually use this example and plug everything in, and we can get our answer. So 2 pi times 3 times 3 plus 9. Let me know what you get. Probably got 36. In terms of pi, yeah. There we go. So we got 36, but then you have to multiply it times 2. I don't know who's calling me. So we end up with 72 pi centimeters squared. So again, we have a formula. Formula helps, but if you forget the formula, you have to remember that this is what you're adding together. We were adding together the area of this circle, the area of that circle, which are the same, and then the area of the rectangle. And then with the rectangle, the height, the length is the height, and the width is the height, and then the length would be the circumference. Any questions? This one's a little bit more tricky, so please make sure that you're taking a look and you're understanding where everything comes from. I'll do a little bit of highlighting. I know that this will be helpful just to see where everything comes from. So that was the area of the rectangle right here. Area of the circle, you should already know where that comes from. And then we were just combining everything. No questions? Okay, let's try one together. Actually, 2 of them. So I'll start you guys off. I'll just make sure we remember the formula. But then from there, you should be able to plug everything in with no problem. 2 pi r times r plus h. Go ahead, do number 7 and do number 8. Yes, leave it in terms of pi. All right, 30 more seconds. All right, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, for number 7, what's the radius? That's too easy. That question's way too easy. What am I? What are you? 6th graders? We just fill everything in. Matter of fact, the fact that I didn't get that many responses in the chat is troubling to me. That is troubling. That tells me that y'all are either not doing it or I need to call Miss Weaver because this is very simple stuff. If you already have the formula, this should be very, very easy. Very, very easy. So I'm doing 2 times pi times 6 times 6 plus 15 gives me 21. Stick that all in your calculator. 2 times 6 times 21. What do I get? $252 centimeters squared. Number 8, same thing. In this case, you just have to be a little careful because they don't give you the radius, they give you the diameter. So half of that is what? Good, 30. Well, Jalen sent it privately, but 36, good. All right, what's 36 plus 80? $106. Wait, 116 or 106? 116. Yeah, 116. Okay. And now multiply it all together and we'll get our final response. Good. 8,352 pi. What are the units? Not centimeters, but good, millimeters. That's my surface area. All right, so let's just quickly review everything so far. We have a formula for cylinder. We have a formula for rectangular prism. The only one that we don't have a good formula for is rectangular prism, but we know that with a triangular prism, but we already know that we just have to add up all of the areas. So if you got to do it the long way, you can just do it the long way. There's no harm in that. Either way, we know we're just adding all the areas up together. All right, we've done prisms, we've done cylinder. Now let's move on to pyramids. Now I don't have the net of this pyramid here because I want us to try to come up with it together. What are the different faces of this pyramid? Or in other words, if I broke it all apart, what would I end up having? What type of shapes would I have? What are all the different shapes I would have in here? Triangles and squares. So I have a square in the middle. What? Okay, can you turn your sound on so we can hear it? Or your mic?
Good afternoon. Once again, students, you would have received to your email your testing site for Thursday. Your testing site for Thursday, you would have received an email. Teachers, you also have the list of students and their testing locations for Thursday. Before we get ready to do our drama, on the last block of the day, on our sixth period, teachers, if students are unsure of where they are going for sixth grade on Thursday, that you go over that information with them now. So they may have their testing sites if they can't access their email. Thank you.
Okay. So if you're testing on Thursday, you should have received an email. So the important thing is to make sure that you're checking your student email. Okay. Anyways, so we concluded we have a square and then we have how many triangles? We just have 3 triangles. Oh, 4. Okay, we have 4 triangles. Okay, are the triangles the same or are they different? They're different? Perla says they're the same. Let's get some confirmation in the chat. What does everyone else think? Are they all the same triangle or are they all different triangles? Same, same. Okay, good. Now the reason that they're the same is because this is a square pyramid. And that's something very important. You have to read it carefully. Since I have a square, that means that all 4 of the sides will be congruent. All of these are 5. Okay, so because of that, all 4 of my triangles are also the same. Now, let's see, okay. In that case, let me draw a net. So when I draw this net picture, like you take each of these sides and you're just gonna open it outward. Okay, and I'll show you what that looks like. But if you kind of picture like you can take a pyramid from the top and just open it up, it would kind of look like a star, yeah. So here's the square for the center. Let me move this over. And then you would have one triangle over here, there, there, and there. So for this specific pyramid, here's the 5. All of these are 5 units. And then they give us the height. They say the height is 9 units. So that's 9, 9 for all of them. Questions on how to make this net? All right, cool. Well, I'm going to erase it because now let's make our formula. Oops. So the formula would be, we have one square. So the square, and then we have 4 triangles and they're all the same. So 4 times the triangle. Now, if we call this length, width, or no, we can call these S. These are all sides. And then 9 is my height. What would be the area of the square? The area of the square. What are you multiplying to get it? Good, 25, right? So I'm just going to quickly write S squared. So we know it's the 2 side lengths squared. Then what would be the formula for the area of this triangle? Just one of them. And then we'll multiply it times 4. Good. 9 times 5 over 2. Or you can write it as 1/2 times 9, or 1/2 base times height. Well, the base is the same as S, right? The base is this, it's 5. So I'm just going to replace that with an S. And now let's kind of see if we can combine anything. What would be 4 times 1/2? 2. Now, what do both of these terms have in common? The S, good. So we can keep one of these, because technically this is S times S. So if I factor out an S, I'm left with S plus 2H. And there's my formula for the,
Wait, miss, what happened to the third S?
which third S?
The one with SH.
Right here?
Wait.
We factored it out.
Oh, yeah. Okay, never mind.
Factored it out. So anytime you factor something out, it ends up inside the parentheses, and then you bring down everything you're left with. So I have my formula, and now I can actually plug things in, and let's get our answers. So 5. So this is a 5. I know that my 5s sometimes look like S's, so I'm trying to be careful. All right, let's go ahead and see what we get. $115. Do we agree? Do we disagree? Perla agrees. Anyone else agree? Anyone else disagree? All right, Tyrone agrees as well. That's 3 people. That's good to me. Yes. So this would be 5 times 5 plus 18, which is 5 times 23, which gives you 115 inches squared. So there's another formula to add to our list. But again, I can't stress this enough. The formulas are awesome if you're good at memorizing them and you want to memorize them. They're great. However, we could do it the long way as well. You find the area of the square at the bottom, you find the area of the triangle, multiply that times 4, you're good to go. So just make sure that you understand that you don't need to memorize these formulas, because if you forget them, you're not in trouble. You can still figure things out. All right, we have just enough time for this cone. I want to actually do the cone, and then hopefully we have time. Maybe we'll go back and do this practice problem, but cone is probably the hardest one. So for cones, I'm going to help you through the process of figuring out the formula, but the formula for cone is probably the only one that you should memorize. And the reason for that is because this one's the hardest to figure out or to see otherwise. So if you don't have this one memorized, you might have trouble figuring it out. But let's just start through it. So first off, there's a little boxes here because they want us to fill these in. So what is this one pointing at? What are we pointing at here? Anyone? Okay, that's R. What about this one over here? What would this be? Try and visualize it. Look at the cone. What is this one referring to? It's not the radius because the radius is this smaller one.
Is that an L? L? L?
L,
Is it
yeah,
L?
it's an
Is it
L.
L?
Yes, exactly. So here's what this is. So basically think about a party hat. Think about a party hat, which is a cone. If you take a party hat and you cut it, just straight up cut it, and you unwrap it and you try to make it really flat, this is what it's going to look like. It's going to look kind of like a Pac-Man, like this. And this length right here matches up with this length over here. And if you kind of brought these two together, if you forced them together, you would make your party hat. Okay, so this is the length. And then this is the radius. Now, the surface area is going to be the area of the circle, we'll call it C, plus the area of this. Now, what's going on here? I have almost a full circle, right? It's not the whole circle, but it's part of a circle. So one way to talk about that is that you have, I don't know, I like to call it a Pac-Man, but it's part of a circle. So it's going to be a fraction of the whole circle. So I can't really fill that in yet because I don't know what the fraction is yet. We have to figure that out. But let's start with this circle because that we can figure out. What's the area of circle D? We don't have any numbers yet. We're just using area formula. Pi r squared. That we already know. Okay. Now, what would be the area of this entire circle? If we're using the letters that we have in front of us. What would be the area of the big circle using the letters we have? So we know the formula for circle. Okay, it would be pi L squared. Pi L squared. But we already know that that's going to be a fraction of the whole thing. But we don't know what the fraction is yet. So I'm just going to put x times pi L squared. I don't know this fraction quite yet. This is going to be some sort of fraction, part of the whole thing. But if I'm trying to figure out part of the whole, a part of the whole, that should kind of ring something in your head because we've kind of done this before. Do you guys remember where you would have part of the whole circle and you have to find the sector area? Sector area. Anyone remember that? I'm sure you do. If I wanted to know the area of this sector, what type of equation would I have to set up? Anyone recall this? It's a proportion, yeah. We can use this proportion to figure out the fraction of the whole circle that we're talking about. So this is technically a sector. Because remember, sector is just a part of a circle. So this whole thing over here, we're going to call that a sector. So now here's the letter I'm going to fill in. This is the sector. So it's the area of the base, which is this circle. That part's easy. But now we have to figure out the area of this sector. And I don't think we're going to have time, which is fine. We can do this tomorrow. But just to start setting it up really quickly, here's my last question. Can anybody tell me what this is going to be? So picture your party hat. You just cut it and you opened it all flat. But if you put it back together, what would this make? Anyone? Picture it. What I might do for tomorrow, I might actually get a party hat. I'm not even kidding, because it's going to be easier to see it.
Can I buy one?
You can if you want to. But let's see if anyone can figure this out. If I bring, okay, let me, I only have 1 minute. Okay. If I bring these two blue sides together and I shut them, what is going to happen to this purple part? Actually, let me make it orange. If you bring together the two blue segments, you line them up, you got to tape them together or staple them together. What's going to happen to this orange part? It's not going to get bigger because we're bringing them together. Remember that this is the net. So this is what happens when you take it apart. But if I put it back together, I'm just going to go back and get my original cone. So that orange part is this right here. And we'll pick up on this tomorrow. So I'm not going to assign your homework tonight. I'm going to assign it tomorrow night because we didn't finish. So we'll come back tomorrow. We'll finish this, do one more thing, and then we'll be done with surface area. Bye, everyone. Have a great day.
I need to make sure my mic works this time.
Yeah, you do. Bye, Jalen.